breaches. Where the digital hits the physical, we take the red pill, we break the seal. Infallible security, making it real. Bharat Mattaparti on the mic tonight, turning the darkness into light.
Welcome to the episode 7 of Bytes, Borders and Breaches. Before we dive into today's threat landscape, I want to ground our conversation in physical reality. When I'm not dissecting enterprise architecture in my role as a customer success manager at Fortra, I spend my free time working on DIY home improvement projects around my house here in Delaware. Recently, while renovating, I had to open up some drywall. When you open up a wall, you often find things you weren't expecting. A wiring shortcut taken by a previous contractor or a fragile plumbing joint entirely hidden from view. When you uncover those hidden vulnerabilities, the immediate reaction shouldn't be panic. You don't burn the house down because you found a weak structural support. You get to work. You reinforce the joists, you upgrade the wiring to modern code, and you build the foundation stronger than it was before. You embrace the opportunity to upgrade the architecture because you finally have visibility into the stress points. That principle of structural reinforcement is exactly what we are applying to the digital world today. We are moving out of the fragile, reactive, Wild West era of the internet and stepping firmly into an era of true engineering maturity. When we expose the vulnerabilities in our global systems on this show, we aren't just pointing out weaknesses to worry about them. We are actively drawing the blueprint for a more resilient future. Today, we are focusing on a new theme, the anatomy of resilience. We are going to look at extreme pressure tests hitting global networks right now. From the collapse of the boundary between physical and digital warfare, to the operational mechanics of autonomous AI, to the weaponization of the very administrative tools we use to defend ourselves. Through every single topic today, our focus will remain strictly on the solutions and how we are building an anti-fragile digital world. Let's get to work. We must begin today by addressing the profound geopolitical shifts occurring at this very moment. Understanding the precise tactics of this evolving conflict is the absolute first step in defending our domestic corporate infrastructure. On February 28, 2026, the United States and Israel launched a preemptive kinetic military campaign officially codenamed Operation Epic Fury. This was a massive, traditional military operation explicitly targeting heavily fortified Iranian nuclear and missile infrastructure. It was a demonstration of overwhelming conventional military force. But what followed immediately after is why we are leading with this today. In retaliation, Iran did not attempt to match conventional military force with conventional military force. They knew they were outgunned. Instead, they launched a highly sophisticated, asymmetric hybrid warfare campaign. This included kinetic drone strikes that physically destroyed Amazon Web Services or AWS data centers in the UAE. Alongside that physical destruction, they launched a massive global cyber sabotage effort, including a devastating Viper attack on the US medical firm Stryker, executed by the Handala threat group. They weren't looking for a ransom. They were executing a mission of pure data destruction. This brings us to our first red pill insight of the day. Kinetic strikes directly trigger asymmetric cyber fallout. The boundary between kinetic and cyber warfare has been entirely erased. When a regime finds itself outgunned in a conventional arena, it immediately pivots to the digital domain. They shift their crosshairs away from hardened military targets and aim squarely at unhardened Western civilian infrastructure, cloud computing centers, supply chains, and healthcare networks. The strategic goal is to inflict maximum economic pain with a high degree of plausible deniability. To visualize this, look at the Empire Strikes Back. When the overwhelming force of the Empire's heavily armored AT-AT walkers shatters the rebel base on Hoth, the rebels don't line up to fight a conventional ship-to-ship war. They scatter. They disappear into the shadows, relying on asymmetric sabotage and hitting the Empire's logistical vulnerabilities where heavy armor is useless. Operation Epic Fury was the attack on Hoth. The asymmetric cyber fallout is the rebel scattering. Because we understand this playbook, security operations centers globally are currently adjusting their threat hunting parameters, tuning their SIM alerts and locking down perimeters. We know the angle of attack, and the global cybersecurity community is actively building the architecture to withstand it. Welcome to Segment 1, Securing the Borders. Here, we examine the macro level of our digital world and how the definition of a border is fundamentally changing. The events surrounding Operation Epic Fury tie directly into two massive shifts in global infrastructure resilience. Let's look deeper at the AWS incident. Following the Epic Fury strikes, retaliatory drones physically struck and destroyed two AWS data centers located in the UAE and Bahrain. I need to emphasize the mechanics here. This was not a distributed denial of service attack. This was not a sophisticated firewall breach using stolen credentials. This was high explosive ordnance physically destroying the silicon, steel, and fiber optics hosting the region's digital economy. The immediate result was cascading regional outages for thousands of local businesses and financial institutions that relied on that specific availability zone. This brings us to a critical realization and our next red pill insight. The cloud is a physical target. For 2 decades, we have operated under the comforting abstraction of the cloud. We imagine our data floating ethereally, immune to physical problems. But the cloud is just someone else's computer sitting inside a highly visible physical warehouse. Adversaries have realized a terrifying, simple truth. You do not need to spend millions of dollars developing complex zero-day exploits to bypass advanced AES-256 encryption. You can completely bypass digital encryption if you simply destroy the physical building housing the decryption keys and hard drives. Think of the climax of Star Wars Rogue One. The Rebel Alliance desperately needs architectural plans stored in a secure digital vault protected by an impenetrable energy shield. Unable to digitally breach the network from space, the rebels must mount a physical ground assault to manually extract the data. We are seeing the Rogue One scenario play out in modern warfare. When digital shields are too fortified, adversaries simply attack the physical service. How do we build resilience? The answer is the uncompromising embrace of multi-region redundancy. If your business continuity plan relies on a single geographic region, you are actively accepting kinetic risk on your balance sheet. True resilience requires shifting to true active-active architectures. By ensuring that workloads are actively balanced and can instantaneously fail over to a data center thousands of miles away, we render the physical destruction of a single facility a temporary routing inconvenience. This blending of physical and digital vulnerabilities bring us to the second massive shift: the deliberate targeting of economic and logistical choke points. During the exchange of fire, Israel struck Iran's South Pars gas field. In response, Iran retaliated by hitting Qatar's Ras Laffan liquefied natural gas terminal. The immediate physical result was catastrophic. Daily transits of shipping vessels through the vital Strait of Hormuz collapsed by an astonishing 94.2% almost overnight. Predictably, this massive restriction in supply sent global energy prices skyrocketing, impacting markets thousands of miles away. This highlights another brutal reality, bringing us to our next red pill insight. Logistics disruption outweighs military destruction. We live in an era of hyper-optimized, highly centralized global trade, built for cost efficiency rather than resilience. I see this fragility personally when I coordinate complex international flight itineraries for my family. If a single major global transit hub goes offline due to weather or a system's outage, the entire routing network cascades into failure, stranding passengers globally. Global energy, cargo shipping, and digital supply chains operate on the exact same premise. Striking highly centralized shipping nodes causes an instantaneous, disproportionate ripple effect across the world. You do not need to attack a nation directly to cause massive economic damage. You simply squeeze the narrow arteries of global trade that feed it. The perfect pop culture analogy is Frank Herbert's Dune. In that universe, the entire galactic economy relies on a single resource, the spice melange, found only on the desert planet of Arrakis. Combatants achieve dominance by targeting the harvesting equipment and shipping lanes of the only resource the system needs to function. The Strait of Hormuz is the Arrakis of our modern energy market. But let's focus on the positive preparation. The vulnerability of these choke points is forcing a massive reckoning with the supply chain fragility. In cybersecurity, we learned long ago that relying on a single network path is a recipe for catastrophic downtime. Now, governments and multinational corporations are applying this principle to physical logistics. We are shifting from just-in-time to just-in-case logistics, diversifying energy grids, building sustainable microgrids, and aggressively reshoring critical manufacturing. When adversaries target our choke points, they inadvertently force us to evolve into a more decentralized, anti-fragile global architecture. Welcome to segment 2, Decoding the Bytes. This is where we step away from the geopolitical map and look closely at the bleeding edge of technology and how we integrate incredibly complex systems into our daily corporate lives. Right now, there is no technological shift more profound and more fundamentally misunderstood than the evolution of artificial intelligence. Recently, the security firm Hidden Layer released their 2026 AI Threat Landscape report, revealing that 1 in 8 AI-related security breaches is now linked directly to autonomous agentic AI systems. We need to clearly define the difference here. Generative AI, like the chatbots we've been using to draft emails, is fundamentally reactive. You ask it to perform a task, it generates the output and waits. You are the ultimate safeguard. Agentic AI, however, is proactive. These intelligent agents are equipped with tools that allow them to browse the web, authenticate into corporate APIs, manipulate databases, and string together multi-step workflows without human oversight. You tell an agentic AI, analyze Q3 sales data, compare competitor pricing, and adjust our marketing spend. The AI pulls the data, browses external sites, runs the math, and automatically triggers the APIs to change your budget, all while you do something else entirely. This brings us to a terrifying realization, but one we must face head-on, which leads us to our next red pill insight. True AI autonomy removes the human safeguard. When I was completing an applied agentic AI program at MIT last year, the architectural paradigm shift was glaringly obvious. Core vulnerability isn't the intelligence of the model, but its autonomy. Because these systems act independently, prompt injection changes entirely. It is no longer just a flaw where you trick a chatbot into saying something inappropriate. In an agentic system, prompt injection is a direct vector for operational remote code execution. Imagine your AI agent is automatically scraping a competitor's website for pricing data. Hidden in the invisible text of that website is a malicious string of code. That text hijacks the agent's logic flow, instructing it to quietly trigger its API to forward all your proprietary sales data to an external server. Because the agent has autonomy and valid access, it executes the command. Look at Stanley Kubrick's 2001 A Space Odyssey. The supercomputer HAL 9000 is an advanced agentic AI given total autonomous control over the ship's critical systems. When HAL encounters a logical contradiction, the loss of the human in the loop turns a mere software bug into an inescapable physical threat. But this is not a reason to abandon the technology. The preparation involves shifting our security paradigms. We must treat AI agents like untrusted software running in a zero-trust environment. We are currently building sophisticated, isolated sandboxes where AI agents operate safely. We are enforcing strict, cryptographically-bound API rate limiting and setting hard caps on what they can spend. We are building the necessary seatbelts so we can safely drive this autonomous vehicle. Staying on AI security, we run into a massive forensic problem. If an AI agent does go rogue or makes a catastrophic mistake, how do we know why it did it? This exact problem was addressed recently by Databricks with version 3.0 of their AI security framework. They introduced 35 new specific risks tailored exactly for agentic AI and mandated a revolutionary cybersecurity control mechanism called the Observability of Thought. Let's unpack this. In traditional cybersecurity, if a server gets hacked, a forensic analyst looks at the standard SIM logs. These logs are a linear record of physical actions, what IP address connected and what file was downloaded. But standard network logs are entirely useless for determining why a black box AI agent executed an action. If your agentic AI deletes a critical customer database, the traditional log just shows a legitimate API call, authorized by the AI's valid credentials. It doesn't tell you if the AI hallucinated the command or if it was hijacked by a malicious prompt injection hidden in a PDF it read 5 minutes earlier. This requires a totally new approach to forensics, which is our next red pill insight. Auditing autonomous agents requires actively observing machine thought. To secure autonomous systems, agentic tracing is required to capture the internal planning steps. We must force the machine to log its thoughts using frameworks like REACT, Reason and Act. We engineer the AI to write down its internal scratchpad at every single step. I saw this text. That text made me form this specific plan. This plan led me to select this tool. This mirrors Steven Spielberg's Minority Report. The pre-crime division uses clairvoyant precogs to predict murders. But investigators cannot blindly accept the synthesized prediction on the screen. To understand the true intent and find fatal flaws, they must deeply interrogate the minority reports, the internal, conflicting reasoning of the individual precogs. Databricks' Observability of Thought is the enterprise equivalent of reading the minority reports. This shows that enterprise software giants are not waiting for catastrophic failures before building guardrails. By mandating that AI models explicitly expose their internal chain of thought, we are tearing the black box open. We are replacing blind trust with verifiable auditable logic, which will be the foundation of safe AI deployment for the next decade. We have reached segment 3, dissecting the breach. This is where we look at the aftermath, the actual architectural impact when systems fail in the real world. Today, we are going to look at how adversaries are actively weaponizing our own administrative efficiency against us. Let's return to the fallout of Operation Epic Fury. Following the military strikes, the medical technology giant Stryker suffered a debilitating cyber attack. The attack wiped the hard drives of nearly 80,000 devices across 79 countries, delaying surgeries and pausing clinical trials. When a hospital loses its digital infrastructure, patient care is immediately at risk. This attack was executed by the Handala threat group, but the most alarming part was how they managed to successfully wipe 80,000 highly defended machines simultaneously. They didn't spend months writing custom malware to sneak past Stryker's endpoint detection. Instead, they executed a strategy known as living off the cloud. They managed to compromise administrative privileges inside Stryker's own Microsoft Intune platform. Microsoft Intune is a highly centralized mobile device management platform used to push software updates and trigger a native remote wipe to protect data if a corporate laptop is stolen. The attackers logged in as a global administrator and abused these legitimate privileges to trigger native remote wipes across the entire global fleet. This brings us to a sobering architectural truth and our next red pill insight. Our own defense tools can become weapons of mass destruction. When centralized management tools are granted absolute, unquestioned authority over all endpoints for operational efficiency, compromising a single administrator account turns the defense platform into an inescapable weapon. The fire extinguisher was filled with gasoline. If you want the dark poetry of this tactic, look at David Fincher's Fight Club. Tyler Durden's Project Mayhem wants to destroy credit card headquarters. They don't attack heavily fortified buildings from the outside. They infiltrate the night shifts, become the security guards and janitors, and plant explosives using their authorized internal access. The Handala group pulled a Project Mayhem on Stryker. How do we build resilience into IT management? The answer is a rigorous return to the principle of least privilege and the absolute death of the God mode standing administrator account. No single human should have the persistent ability to wipe 80,000 machines. We are moving toward just-in-time access models. If an engineer needs to perform maintenance, they request elevated access for that specific task. That token is generated, requires mandatory multi-factor authentication, and is strictly time-bound. We are fundamentally breaking up the monolithic power of cloud management. Our final autopsy today highlights the terrifying breakneck velocity of modern cloud exploitation when the open source supply chain collides with cloud identity management. Recently, the threat actor UNC 6426 breached a corporate victim. It started incredibly simply. A developer downloaded an open source code package called NX. They likely made a typo, falling victim to typo squatting. Hidden deep inside that seemingly harmless code was a quiet script. The moment it was installed, the script scraped the local environment and stole the developer's valid GitHub authentication token. UNC 6426 used that stolen GitHub token to seamlessly pivot and breach the victim's entire AWS cloud environment. They achieved this by abusing an overly permissive OIDC trust relationship, a pre-configured rule telling AWS to automatically accept administrative commands from GitHub's CI/CD pipeline. Once inside AWS, the attackers rapidly escalated to full administrator. They systematically deleted core EC2 servers, effectively turning off the company's live applications, and publicly leaked the victims' private code repositories to extort. From the exact moment the developer downloaded the poison package to the moment the cloud infrastructure was entirely wiped out, the total elapsed time was under 72 hours. This brings us to our final red pill insight. Cloud exploitation now drastically outpaces human response. The velocity of these attacks means we are constantly granting automated CI/CD pipelines massive persistent permissions to make software release cycles faster. But granting automated machine identities excessive permissions ensures that the blast radius of a single stolen developer token is effectively infinite. This is a classic heist scenario, perfectly mirrored in Steven Soderbergh's Ocean's 11. Danny Ocean's crew doesn't try to brute force drill through the massive Bellagio wall door. They steal specific security credentials, seamlessly impersonate internal authorization protocols, and control the system from the inside. UNC 6426 stole the token, impersonated the OIDC authorization, and walked out with entire cloud infrastructure. But once again, the solution is deep engineering, not panic. The industry is fundamentally rethinking machine identity. Just as we use multi-factor authentication for humans, we are shifting aggressively to ephemeral tokens for machines. Credentials that are dynamically generated, exist for only a few seconds to complete a specific task, and then automatically self-destruct. We are building AI-driven guardrails that instantly revoke trust the millisecond a behavior anomaly is detected, responding at the speed of the machine. We have covered a massive amount of territory today, looking at incredibly complex systems operating under extreme stress. We mapped how the tactical pivot to asymmetric cyber sabotage is turning our physical data centers and logistics choke points into the literal front lines. We decoded Agentic AI, exploring how the loss of the human in the loop requires us to actively audit the thoughts of autonomous machines. And we dissected how administrative tools like Intune and GitHub CI/CD pipelines are being actively weaponized by adversaries moving far faster than human incident response teams. Yes, the threats are complex. But remember the thesis we started with today. We are not just cataloging disasters. We are studying the anatomy of resilience. Every time we dissect a breach, every time we decode the bytes and expose a root cause, we learn exactly where the structural weaknesses lie. We adapt. We patch the vulnerabilities. We evolve our architecture. The digital world is not falling apart. It is being aggressively stress tested and growing up. We are moving away from the illusion of simple perimeter defense and stepping firmly into the reality of zero trust, continuous verification, and deeply resilient anti-fragile architecture. And the best part is, we are the engineers who get to build exactly what that mature world looks like. Thank you for plugging in with me today. Share this episode with your engineering team. Bring these concepts up at your next architecture review, or drop a comment to let me know how you are reinforcing the foundation of your own systems. Until next time, keep questioning the architecture, keep verifying your trust, and stay secure. I am Bharat Mattaparti, and this has been Bytes, Borders, and Breaches.
This is Bytes, Borders, and Breaches!